Here we're going to talk about multiplying and dividing radicals. So let's start off with an example here. We're multiplying 2 root 5 times 7 root 12. Okay, so because this is all multiplication, we can multiply the 2 and the 7 together to get 14, and then the square root of 5 times the square root of 12. Remember that the nth root of a multiplied by the nth root of b, right? Because the indices are the same, that's the nth root of a multiplied by b. So you can multiply the radicands together when the indices are the same. So the square root of 5 times the square root of 12 is the square root of 60. And then we can simplify that, so we get 14 times the square root of 4 times 15. And the square root of 4 is 2. So we have 14, let's write that as first square root of 4, square root of 15, and square root of 4 is 2. So 14 multiplied by 2 multiplied by the square root of 15, and our answer is 28 times the square root of 15. Okay, so let's go ahead and try another example like that. Okay, so here we're multiplying 2 times the square root of 3x minus the square root of 5 times itself. That is, we're squaring that quantity. So let's write that out first as 2 square root of 3x minus the square root of 5 multiplied by itself. So 2 square root of 3x minus the square root of 5. Okay, now we're going to take this 2 square root of 3x and we're going to distribute it. So first we're going to multiply it by this quantity, and then we're going to multiply it by the negative root 5. And after that we're going to take negative root 5, multiply it by 2 times the square root of 3x, and then negative root 5 times negative root 5. So first, 2 root 3x times 2 root 3x, well, 2 times 2 is 4, and the square root of 3x times the square root of 3x, that's just equal to 3x. And the reason is because the square root of a multiplied by the square root of a is always just a. So square root of 3x times the square root of 3x is just 3x. So we still have the 4 times the just 3x. And now 2 times the square root of 3x times negative square root of 5. That's going to be, let's see, negative 2, and then the square root of 15x. And I got the 15x by multiplying 3x by 5. And now we move on to the negative square root of 5. So negative root 5 times 2 root 3x is going to be negative 2 square root of 15x. And now negative root 5 times negative root 5 is positive, and root 5 times root 5 is just 5 using this property once again. Okay, now we get 12x, and these two radicals are like radicals. And like radicals are ones that have the same index, a 2, but also the same radicand, a 15x. So you combine like radicals by adding the coefficients. That is, negative 2 and negative 2 is negative 4. And then you still have the square root of 15x plus 5. And at this stage we can't go any further because we don't have any like terms to combine. So this would be our answer. Okay, so let's go ahead now and talk more about simplifying radicals. So generally when we simplify radicals, we're going to follow 3 rules in order. First of all, we want no fractions under the radical symbol. So for example, under the radical symbol right now, I don't have any fractions. Second thing is we want no radicals in the denominator. Well, I currently here have a radical in the denominator, so we want to get rid of that. And when you do that, when you get rid of radicals in the denominator, that's called rationalizing the denominator. And then once we do that, we want no perfect powers under the radical. So let's go ahead and go through and simplify this problem here, or this expression. So first of all, I notice that the index is a 3. And that makes me think about perfect cubes. Now in the land of perfect cubes, there is the number 8, which is 2 cubed. There is 3 cubed, which is 27. There's 4 cubed, which is 64. 5 cubed, which is 125, and so on. Now I really wish this was a perfect cube, because the cube root of a perfect cube is easy to find. So what can I multiply that 2 by to get one of these perfect cubes? Well, I can multiply 2 by 4 to get 8. So now that's what I'm going to do. But remember, I can't just write a 4 right here because this is a radical. So what I have to do is I have to put the cube root of 4. Only when these are both cube roots can I multiply the radicands together. So 2 times this 4 will be 8, and they'll both be under the cube root. Now whatever you multiply the denominator by, you have to multiply the numerator by as well. So that's the cube root of 4 up here as well. Okay, so what do we have in the numerator? Well, it's going to be 3 times the cube root of 4. And the denominator, this is the fun part, is going to be the cube root of 8. And then, of course, that numerator we can just leave as 3 times the cube root of 4 over the cube root of 8, which is 2. Now notice how this number, the cube root of 2, that is an irrational number. Notice what happened. I turned that into a rational number. And that's why we call this step, that is getting rid of radicals in the denominator, we call that rationalizing the denominator. So this was step 2, to get a rational number in the denominator. And then step 3 says no perfect powers under the radical. Well, this is a perfect power here. 4 is a perfect square, but I'm not worried about that because the index is a 3, and I only have to watch out for perfect cubes under the radical. Okay, so this would be our answer. In other words, that third step right there, no perfect powers, that you only have to worry about what the index is. Okay, so no perfect cubes in this case. All right, let's try another one like that. Okay, let's simplify this one, kind of complicated. So we're going to handle this like we handled the previous one, and that is, I really wish this was a perfect cube. Well, what can I multiply 3 by? Well, 8, right? There's no whole number that I can multiply 3 by to get 8, but remember, 8 isn't the only perfect cube. There's also 27, there's also 64, 125, and so on. So clearly, I want to multiply 3 by, well, to get 27, it's going to be 9. So let's write that out. It's going to be the cube root. Don't forget the cube root. It's going to be 9. That's to make 27. Now, I really wish this was x to the what? Well, x to the third. So that's why I'm going to put an x squared here, so that when I multiply those together, that becomes x cubed. And likewise, this is going to be a y. That's because y times y squared will be y cubed. And that means we have to multiply the numerator by the same thing. That is the cube root of 9x squared y. Notice that when you rationalize the denominator, it's all about the denominator. I'm not concerned about what's happening in the numerator just yet. So in the numerator, when I multiply these together, I get the, let's see, the cube root of, it's going to be 63 x to the fourth, y to the fourth. And in the denominator, we're looking at, well, the cube root of, it's going to be 9 times 3, which is 27. We're going to get an x cubed, and we're going to get a y cubed. Okay, so still putting that numerator on hold for a minute, it's going to be the cube root of 63 x to the fourth, y to the fourth. Okay, divided by, okay, now the cube root of 27 is 3. The cube root of x cubed is x, and the cube root of y cubed is just y. So we rationalize the denominator. Now, of course, now we have to think about perfect powers under the radical, and I'm thinking about perfect cubes. There is no factor of 63 that's a perfect cube. So 63 can remain as it is, but x to the fourth I'm going to write as x cubed times x, and y to the fourth as y cubed times y. So let's write all that way up here. So it's going to become the, let's see, the cube root of 63, we said x cubed times x, and y cubed times y, over that denominator, which is 3xy. Okay, now the cube root of that x cubed right there, that's going to become an x. So I'm going to have an x, and the cube root of y cubed is going to be y, and we still have under the radical, well, the 63 hasn't gone anywhere, right? And notice that this x is still there. And same thing with this y. Those two haven't moved. And then all over 3xy still. And now we can simplify a little bit. And the reason is because we can cancel these x's. So the x with the x, and the factor of y with the factor of y, and there's our answer. It's going to be the cube root of 63xy divided by 3. That's as far as we can go with this one. Now it turns out you can do this problem another way. Do you see how it's the cube root of something divided by the cube root of something? What you can do is you can create a giant cube root, and you can write this radicand divided by that radicand. So under that giant radical, we can write 7x squared y cubed divided by 3xy squared. And then, why would you do that? Because now you can cancel, right? X squared divided by x and y cubed divided by y. So once you cancel, then you're going to want to follow the three rules that we had a moment ago for simplifying the radicals. So as an exercise, I would like you to do this, simplify right here, and then use the rules to simplify the radicals and see if you can get the same answer that I got here. Either way is okay, and this will be a nice exercise for you to try. Okay, let's try another one. Because you know, these are kind of tricky, and getting some experience with them is helpful. Okay, so first of all, for the first one, I noticed that I have a fraction under the radical. So what we do is we first break that up as the square root of 3 divided by the square root of 7. And that's good. We got rid of the fraction under the radical, right? But now we have a radical in the denominator. So I'm going to multiply top and bottom by the square root of 7. Square root of 7. So that's going to be the square root of 21 divided by, and the square root of 7 times the square root of 7 is just 7. And then finally we ask ourselves, do we have any powers under the radical? And the answer is no, so this would be our final answer. Okay, now for the next one here, simplify 3 divided by the square root of 5 plus 3. Notice that you have a radical plus something else. And that's different than this, right? Here you had a single radical in the denominator. When you have a radical or a square root as part of a sum or a difference, you have to do this extra little trick. And notice that if you multiply by root 5, it's not going to work, because root 5 times root 5 will give you 5, but then you'll multiply the root 5 times the 3, and you'll still have a radical down here. So what we do instead is this. We multiply by the square root of 5 minus 3. Okay? So top and bottom by that, square root of 5 minus 3. That is called the conjugate. So when you take a radical expression that's a sum, and you change the sign in the middle, these two expressions are called conjugates. Why would you ever do that? Well, let's see what happens in the numerator. You have to take the 3 and you have to distribute because it's subtraction. So you're going to get 3 square root of 5 minus 9. And then divided by, and watch the magic now in the denominator. The square root of 5 times the square root of 5 is 5. That's no surprise. Okay, now root 5 times negative 3 is negative 3 root 5. And then go on to the 3. 3 times root 5 is positive 3 root 5. Okay, and then let's see, positive 3 times negative 3 is negative 9. And look what happened. The numerator is still 3 square root of 5 minus 9, but the denominator, negative 3 root 5 and positive 3 root 5, those cancel because it's addition. And you're left with just 5 minus 9, which is negative 4. And so the denominator, it has no more radicals in it, right? It's radical free. But we did that by multiplying top and bottom by the conjugate because it was a sum. So this would be our final answer. Okay, let's try one more like that. Okay, let's simplify 2 divided by the square root of x plus 2. Once again, we have a radical, the square root, and it's a sum, so we're going to multiply by the conjugate of the denominator, which is the square root of x minus 2. So the top by the same thing. And what do we get? Well, it's going to be 2 square root of x minus 4. And in the denominator is where the magic happens. The square root of x times the square root of x is x. And let's try to do this next step in our head. Root x times negative 2 is negative 2 root x. And then this is positive 2 root x. And those cancel. And then finally, positive 2 times negative 2 is negative 4. So we write minus 4. And that would be our answer. That's as far as we can go. Okay, so that's how we multiply and divide radicals. Until next time.